Hello, I'm Guillermo Castilla and this is AULA UE. We're going to be working today on discrete models. In this case, the discrete model we're going to be talking about is the hypergeometric model. The hypergeometric model is usually named by this H, N, and P figure that we can see. We're going to explain it through an example. We have a bag of sweets with a total number of 200 sweets in it. Okay, these are the sweets over here. Of those 200, 180 are random assorted sweets and 20 of them are mints. The size of the sample we're going to take from this big bag is of 5 sweets. Okay, and those sweets we're going to take into the sample can be of any kind. They can be either random assorted or mints in any number. I mean, I can have 5 random ones, 5 mints, and any number in between, where I can have 3 randoms and 2 mints or whatever. Okay, so let's explain. This is, we call the total number of sweets n, capital N. We would call the number of random assorted sweets a certain thing, but we're going to call the mints in this case, we're going to call them A, capital A. Okay, and in that case, if the total number is n and the random assorted sweets are A, then the mints are A, then the random assorted sweets are n minus A. Okay, we have the numbers now. We've got n, and what about this P? Well, P is capital A over capital N, which means it's the proportion of mints in the bag. It gives you the probability of finding a mint in the big bag of sweets. So it would be 20 over 200, which is 0.1 in this case. Okay, because it's actually the same thing as 1 over 10, 20 over 200. Fine, so what does the hypergeometric model model? Well, the hypergeometric model gives us the probability of having x mints in a sample of 5, taken from a main group of 200 sweets that include 20 mints. So the hypergeometric model tells us the probability of finding a certain number of mints in the sample. Okay, in this case, how many mints can I have? Well, I can have no mints, so 0, and the maximum I can have are 5, which is the total number of mints in the sample. So it gives me the probability of having 0 mints, probability of taking 5 and finding only 1 mint in those 5, probability of taking 5 and finding 2 mints in those 5, and so on and so forth. Okay, so let's clean this up a bit and go on to the main thing. So the hypergeometric model, the capital N, lowercase n, P, can be described in a bit of a more formal manner as n is the number of elements in the larger group. Okay, capital N. Lowercase n is the number of elements in the smaller group, in the sample. Capital A is the number of elements in the larger group that share a common characteristic. And P is the probability of having the characteristic in the larger group. So it's A over capital N. Okay. Chi, which is going to be our random variable in this case, will describe the number of elements in the sample that have inherited the characteristic from the larger group. Okay. This is a very important factor, of course, because what it explains is how this problem works. So the probability of x being chi, okay, for example, the probability of having 1 sweet in the 5 that I take from the larger group would be f of x when x equals 1, and since it's a model, the f, the probability of chi being x or of x being chi, is always the same. It's always written with the same formula. This formula is the model itself, and it's In this case, well, as you can see, a over x in a Newton binomial times n minus a over lowercase n minus x in another Newton binomial, and all of that over a third Newton binomial, which is capital N over lowercase n. Now, this is relatively simple to calculate. Of course, we could ask for the probability of chi being smaller or equal than x, which instead of being the quantity function, as the one we have up there, would be the distribution function, which is the capital F. Okay, and it's really the same thing as we have, only with the summatorium, because of course we're going to sum every x from 0 to the number we want. So it's from k equals 0 to x, and we'd have in this case a capital A over k in the first binomial, n capital N over a capital N minus a over n minus k in the second binomial, and the bottom one is exactly the same as before because it doesn't have an x or a k. So that would be more or less it. That's how this this model works. It gives me the probability of inheriting a characteristic from a larger group in a smaller one. Let's finish off just seeing a short example on how this goes. Let's talk about the sweet bag again. So we'd have 200 sweets in the bag. 5 sweets we're going to take from the bag as a sample. Okay, we have a proportion of 0.1 mints, which means that there was 20 mints in those 200 sweets in the bag, and so we have our hypergeometric model defined as an H200 5.1. Okay, very well. Well, now that we have the model itself defined, let's ask a question. What's the probability of chi being 2? What does this mean? This is f, the quantity function of 2. What this means is, if I've got a bag of 200 sweets and 20 of them are mints, and I take at random 5 sweets from the bag, what is the probability of having 2 of those 5 sweets being mints? Okay? So what is the probability of just taking 5 random sweets and 2 of them turn out to be a mint? So it would be 20 over 2, okay, a over x times n minus a, 180, over n minus x, which is 3, 5 minus 2 is 3, and capital N over lowercase n on the bottom, on the denominator, which would be 200 over 5. So, as you know, Newton binomials are the top part in a factorial over the bottom part in a factorial times the top minus the bottom in a factorial also in the denominator. So it's 20 over 2 would be 20 factorial over 2 factorial times 20 minus 2, which is 18 factorial, 180 factorial, 3 factorial, 177 factorial. So this would be 200 over 5 factorial times 200 minus 5, which is 195 factorial. Okay, so I'm not going to actually solve this because I put the equal here, but let's forget about it because it's a bit of a messy operation. But this is the idea. This is the probability of having 2 of those elements in that random group of 5 elements, taking completely at random from the bag and finding out that they're mints. Okay? So I hope you found this useful, I hope you understand it, and we'll see you soon.